Hi everyone. So today we will be starting with the topic recursion. This is one of the most important topic that is asked in semester exam as well as in many competitive exam also. 90% of the times you will find these type of questions in exams. So before starting, let's look some of the log formulas that will come in handy when we will be solving the problems. You don't have to sit and learn these formulas. By practicing questions, you will eventually learn. These are some of the important formulas that I have bring to you. You can screenshot this and can keep it for reference. At first, you can look the formulas and can solve the questions, no problem in it. Eventually, when you will be solving many questions, you will learn these formulas and you will also able to differentiate which are the important formulas and which are not. So just take a screenshot of this. I am holding it for a second. Yes, so let's move to our topic, time complexity framework for recursive functions. So to understand this, I guess we have learned about recursion. What is recursion? A function that keeps on calling itself, that is recursion. So first let me write a sample code here. Just a second. So let's suppose this is a function which is terminating at n is equal to 1. If this condition satisfied, it will terminate, and it is also taking to the nearest point by n minus 1. It keeps on detecting the value and brings the function closer to this ending function. So let's understand how to solve a question in recursive type. So first of all, this bn, this is also a function. Let's assume that it takes the time complexity of 1. So first of all, let's write this. Let me change the pen. That b of n is equal to time complexity of 1. Now we have to find the time complexity of this function. So first of all, create an equation. First of all, look at this code. What it's asking. First execution is this. Then we are coming to this. This is big of 1. So we will write it, but we can eventually neglect it. And this is the function that we can, let's say, let's say, call it t of n. And let t of n represents time complexity of what of n. So in this, we can write t of n is equal to t of n minus 1 plus b of n. This is the equation that we will solve to find the time complexity of this. T of n is the time complexity of what? And n minus 1 is the function that we are using, b of 1 is the constant. So to solve this question, let's mark this as, let me write this once again. T of n is equal to T of n minus 1 plus B of n. Now, from this, let's take T of n minus 1 and we will also put n minus 1 here also. And instead of 1, what we are doing? We are keeping n is equal to n minus 1. So here also n is equal to n minus 1, which will give us minus 1 plus, we can neglect this. This is constant. We are treating this as a constant here. So just write big of 1. Here it will be t of n minus 2. So this is our second equation. This is our first equation. Now you have to take the reference of this equation to solve this equation. Example, t of n will be equal to, this is the value of t of n minus 1. We can keep this here. It will become t of n minus 2 plus, let's take it as a variable. Let's suppose d. We are taking this as a value of d for convenience, and here also it was b of n, so we will be also taking d here, which will give us t of n minus 2 plus 2d. Now understand this very carefully. What was the terminating condition for the recursive function? The terminating condition was n should be equal to 1. So what we will do here is, as we got t of n minus 2, we will write n minus 2 should be equal to, so here, sorry, the connection got interrupted. Okay, so back to this. So here, what we got for t of n minus 1 is t of n minus 2. And when we put this, we get this equation, which is d. So let me just sum it up for you. The one equation that we wrote first, it is t of n minus 1 plus d. The second equation that we wrote, it become t of n minus 2 plus 2d. So here we can understand there is a pattern that is keep on following. So we can generalize this as t of, you can generalize this as t of n minus k, whatever times we are doing, k plus k d. Now, as the terminating condition I told you above also, the terminating condition is n is equal to 1. So we have to terminate this function, which is t of n minus k. So what we will be doing, we will be solving this as n minus k should be equal to 1. Now n will be equal to 1 plus k, and n minus 1 is equal to k. Now you can safely write here that t of 1 plus, replacing the value of this, it will lead to n minus 1. From here we got this. Now we have got t of 1 minus 1 and d of n minus 1. So you can open this more if you want to, or else you can directly conclude the answer from here also, here itself. This, we are concerned about this. These are the constant d and all. These are the constant that we took the assumption before. This is the constant which we can say it as big O of n, and we can also say this as theta of n, and also sigma of n. Here we were only concerned about what is the function that we will get. This d and all, these all are constant. We are not concerned about it. Even if there was 3 plus, let's say 4 plus 7 plus 8, we were not concerned about that. These are just constant. It doesn't add the value to our time complexity. Now, let me do one thing. Let me take the same example, and this time we will write that b of n is equal to, let's take the time complexity of big of n. So the approach will be same, nothing will change. the B and F time complexity will change. T of n minus 1, which was before. Now here we were treating as constant in the previous question because their time complexity was big of 1. Here the time complexity is big of n, so it is not constant. So we have to write this also as n. Now let's find for T of n minus 1, which will be equal to T. You have to keep the value of this in this equation. So which will lead to n minus 1 plus n and plus this equation n also, as we are keeping the value of it n minus 1. So here what we will get? We will get T of n minus 2 plus n minus 1. Now from here, what can you conclude from equation 1 and 2? We have to find a common pattern that will keep on following. You can also find for T of n minus 2. Let's find for this also. You will keep this on the above equation, which will be n minus 2 minus 1 plus n minus 2. It will give you T of n minus 3 plus n minus 2. This is the third equation that got formed. Now you have to find the relation between this equation, that what is that common relation that is being formed. And here is this equation and here is this equation. So the common relationship that is being formed is n minus. How many times do are we running? If it's running for second time, we are getting 2. If it's running for 2, we are getting 3. So here it will be n minus k plus k ka. So we have to find the common here. Uh, Let me explain you in this way. Just a second. This is the first equation. This is the second equation that we got. Now you can write like, let me erase this. From 1 and 2, we will be getting T of n is equal to T of n minus 1 plus n. This is the first equation that we got. And for the second equation, what we will be getting is T of n is equal to T of n minus 2 plus n minus 1 plus n. This T of n minus 1, we put this full equation here and then we solve it. Now T of n minus 2 plus 2n minus 1. This is the final that we got. And for the third equation, if we go for, this is from 3. If we go for the third equation as well, here it will form, we were finding for T of n minus 3 plus n minus 2. Now this plus 2n minus 1. Here after solving we will get T of n minus 3 plus 3n minus 3. Now you have to find what is that common equation that is being formed among these. So the common equation that will form there is T of n minus k, 3 times n minus k plus k a plus n minus 1 n minus 2, and it will keep on going till infinity. Now to solve this, we have to find the base condition, which is equal to 1. K will be equal to, as we found above, K will be equal to n minus 1. Here we will put that T of 1 plus Kn minus 1a plus, this is all in n value. We just have to replace the k value plus n minus 2. So it is forming the sum from 2 to infinity, for which the formula is 2 plus 3 plus 4 is going till infinity, for which the formula is n minus 1 divided by 2. As 1 is not included here, we will be minusing 1, which will be n square minus 1 divided by 2 minus 1. You have got the answer. You don't have to solve this complete question to get the final answer. You have got the time complexity. So the time complexities will be big O of n square. You don't have to completely go and solve this full question. You can simply, once you get this time complexity, that's it. And this is the your answer. In future, we will be solving more questions on these. Try to learn the log formulas and try to understand this question again and again. Watch the video. It's easy, it's not that complex. At first, you will find this complex, but as we keep on proceeding with the course, it will be natural to you. Thank you.